So, hi, I am Srihari. Um, the contrast is pretty low. So, that's my name, and that's where I work, and that's the title of my talk. I'm going to be talking about REPL and RDD, my three-letter acronym for the day, REPL-driven development and mobile development. I'm going to be talking a little bit about CLOJURESCRIPT as well, but not as much as other things, and that's probably, like RDD is probably a lot more important. Now, this is where I work, Nilenso. Nilenso is a consulting firm. We are a hackers collective. We've been at this for the last 4 years or so, and most of that has been writing Clojure. Clojure, a programming language, a Lisp written for the JVM. We mostly dabble in functional languages. That appears to be our preference, and we also write, we mostly write backend services, low latency, maintain large databases, all that jazz. And we work for large companies and small companies alike. Now, one of the things that I got when I was talking to people in the lobby and people generally is this, hey, you guys do backend development. You were talking about Postgres clusters and whatnot, and what are you doing there? It's like this, right? For me, I have been doing Clojure for the last 4 years, and the last year or so, I have been doing Clojure still, but on mobile. That's the only difference to me. To me, nothing else has changed. But that said, I'm less like this guy. You guys get the Avengers references, right? I hope you do, otherwise this whole talk is going to be a flop. Okay, so I'm less like that guy and more like this guy because so you guys are familiar with how India leapfrogged into mobile phones, right? A lot of people in the rural areas didn't have landlines and they didn't have to lay cables when they got mobile phones, and suddenly they leapfrogged into the latest technology, and that saved them a lot of time. I'm like that. I don't do native work. I've skipped over all the garbage years of JavaScript, and I'm in the good days. So I have leapfrogged. Why I'm speaking about this is important. Our client had something to build. We had a demo app to build. So a real app for an expo. And they had commissioned a native team to build this. As an afterthought and as an experiment, they wanted us to build this in CLOJURESCRIPT. Now this was a possibility, and they just wanted to try it out. Okay, let's just try this. Our entire stack is Clojure anyway. Let's find out what happens. And turns out, by the time we were closing in on the deadline, we were there already. We were production level quality, and we were focusing on design and fixing extraneous things, while the native team was nowhere close to completing. So that is the footing of my experience on which the talk is based. What I will talk about is why this worked, why the stack worked. What's integral, what's the core in our process that made this happen. I'm going to be talking about RDD. I'm going to be talking about CLJSRN, more words, and undoubtedly some non-tech factors that also influenced how we made this happen. Now, before we go on, I want to establish some basis on our communications. So some etymology or terminology for you guys. A REPL. I was pretty surprised to find out that people don't know what this means. So a REPL is a read, eval, print loop. Basically a computer program that reads your input, evaluates it, and gives you the results. So the most popular example is probably a Python REPL or a Django REPL, Rails console or something like that, where you type a few expressions and then you put together more expressions as you know the outputs of the previous ones, and you incrementally build something that's meaningful, right? So that's the Pythagoras theorem right there. The other thing I want to establish is Lisp. This is probably 60 years old. is 1 year younger to Fortran, and it's been growing still, and Clojure is probably what's brought it to light with its practical approach. So if you get that, I will be thrilled. How many of you get that? Oh well, I have two admirers. So Clojure is a Lisp built for the JVM. It's built by this guy. How many of you know this guy? Oh, good. A few more hands. Great. Awesome. So this guy gave a few amazing talks in addition to like giving us this language. Definitely watch Hamilton Development. It's simple made easy. Then there's CLOJURESCRIPT. Okay, this is basically Clojure that compiles down to JavaScript. And it's been there for like 4 or 5 years now. And this guy, how many of you know David Nolan? Even lesser. Oh, so that's a disappointment. He's a star, guys. Like, go look him up. Like like, talk to Sunil Pai if you want. Like, he'll tell you how much he loves this guy, why you should love him. So CLJSRN, the longest acronym for the day, is basically all the acronyms before this put together. It's CLOJURESCRIPT and React Native, and the combination of these technologies that makes it. But like I said before, it's not the technologies that I'm here to talk about. I'm here to talk about something more fundamental. That brings me to feedback. Right? Here is the most inspiring talk for me in the last 5 years. Brett Victor, Inventing on Principle. If you have not watched this talk, please go watch it. So here he says, and I could relate to this as someone who just came out of college, right? Work in a text editor blindly for like quite a while, you know, like write large chunks of code without knowing whether it's going to compile, whether it's going to run, right? Like I'm sure a lot of you can relate to this. And he says this is wrong, this is fundamentally wrong. And he gives a few examples. Let me walk you through these. So what he has on the right hand side is an editor. On the left hand side is a tree that he's creating using this editor. Right? He has controls on the right hand side, some bars, and he's experimenting with all kinds of weird things that like create different kind of art. But for example, look at this, where he's pointing to a for loop where he says that look, there are 16 blossoms on every branch, and I can turn that up or turn it down based on what I want. And like he moves it between 20 and 30 for a while, and then he looks at a shimmering effect, and he's like, hey, maybe you can use that effect for animation. And there's something he says towards this, like towards the end of this presentation that really captures me. He says, how could I have ever seen something like this if I had to compile and run between every step? Here's another example from Brett Victor's Inventing on Principle talk. He has a game on the left hand side and the code for that on the right hand side. What I'm showing you is static things, of course, but he has a live game. What he's trying to do is get that jumping character to jump on the turtle and go through that small slit on the wall on the other side. Now he can do the same thing. He has the same control of sliders on the right hand side, but he thinks that's not enough. What he does, so he can like change the y velocity on the right hand side up and down, and the character will jump like more or less depending on that, and based on that he can decide that. He says that's not enough. He pauses the game and a slider appears on top. The slider is control of time, right? So with the slider he can hold that, and he has the handle on y velocity. Now he can play with these both. He can like move time forward and backward, and then now he can not execute it, but just quickly move the slider back and forth to know exactly where this character is. That's great. But again he says, that's not enough. What he does is he hits that button there, and the future of the character appears on the screen. What he has effectively done is map time to space. Now take a minute and think about that. These are like, the concept of time and space are always evident in programs, but we don't think about them enough to think of them as tangible things, to make them tangible, to hold them and feel them and like have a good control over them. So this is his principle. Creators need an immediate connection to what they create. Here's another example, and I'll bring this closer to home as I move on. So this is Stephen Wolfram, the creator of Mathematica and the Wolfram language. And here he is in Strange Loop 2014 explaining what it feels like to work with the Wolfram language, and his entire talk is inside the REPL, right? It's just a read eval print loop. He takes a current picture, then he does an edge detect on it, and then what he does is like take that small expression, build on top of it, and then like the last thing that he does is dynamically do the same thing that he did before, and voila. Bringing it closer home is this. There was a deep space probe, it's called DS-1, from NASA, from the Jet Propulsion Lab, and there was a piece of software in it called the remote agent. It was written in Common Lisp. And this guy sitting in front of a computer at a REPL debugged a race condition that never occurred in any dev or test environment, in production, in a probe that's like a million miles away, hundreds of million miles away. Now that's quite something. This emphasizes the importance of debuggability. And bringing it even closer is the things that people have done in Clojure land. Clojure, like I said, is the most practical Lisp of today, and this is where it has brought us. So Sam Aaron creates music live. You should check it out. He also has a library called Overtone. That's great. Zach Oakes makes games. He built an IDE for building games in Clojure. He teaches children through it. And then I have actually spent the last couple of years making music interactively in the REPL as well. I work on modeling and synthesizing Carnatic music. So that brings us to this part of the talk, which is probably the more important one. But I don't want you to forget what we talked about before this. Before we dive in and do some REPL-driven development, this is what happens. I'm assuming that most of you are familiar with the React Native flow, or that has been talked about enough. So I'm not going to, like, that's abstracted out. So CLOJURESCRIPT goes through the Clojure compiler, becomes JavaScript. The Clojure compiler with an S that Google created is an essential part of the compilation process, and it optimizes JavaScript and removes all dead code. And then you get into the React Native flow. So with that in context, let's go into a demo. So I will mirror displace and move to my editor. Okay, do people see this? Can people see the code? Increase font size. Double it. Okay. Okay, what I will do is zoom into things, okay, as and when I'm working on them. So on the right hand side is the IO simulator. The whole thing works as it would on iOS, on Android as well. You just have to take my word for it, or like talk to the React Native folks. I'm not going to be talking about that. I'm going to be talking about the REPL and what RDD is. So you guys are able to see that, right? Here it's a demo app called the Plant Store. I'm building a store to sell plants. So you'll see on the left hand side on my editor, I'm in a namespace called demo app.view. On the right hand side is the simulator. Now, something like this would be quite obvious in the beginning. So you can read this, right? If somebody is not able to read this, please raise your hand. Okay, everyone's able to read. So I have 3 pages here. Each of them has a name, and you can see that it maps to that. So let's go into the splash page. What I'm going to do is jump into the definition. Right, so this is the splash page. Let me zoom in there. So you'll see that this is a function. This is a function name. There's argument list, and this is a Clojure vector, and this thing here is a Clojure map. All Clojure data structures, and this whole splash page is a component. Now I have here a plant store. I can quickly change it into a flower store, and you'll see that that works. But I'm not here to demonstrate that. This you already know from your React Native stories. Let's look at the REPL. Right? Now let's bring this part up. I have access now to my evented system underneath. What I can do is now dispatch events. Right? I'm going to say go to. I have an event called go to, which helps me switch pages. And the list of pages is here. So I can look that up and say, go to the home page, right? And it goes to the home page. And say, go to the plants page. And it goes to the plants page. Let's come back to the home page for a bit. Look at this. So there is a grid of things, right? And then, okay, so let's actually quickly go look at the grid, what that looks like. So there's a menu grid, and look, there's a menu items. Let's zoom into that part. So you see that this is a list of things, and this is a plain Clojure data structure. There's nothing very complicated. There's a list, and there are maps inside. So say there's a decor thing. See, the picture looks nice. Let me bring that up. I moved it up and saved, and it's quickly moved up, right? And you see how this thing is styled. There's a menu grid and whatnot. If you look at the menu title, you see clicking on it says go to plans page. So that's here, that works. And then there is the styles of the menu tile page. So you see what styles is. It's not a separate library that does styling for me. It's just again a Clojure map, right? And here you can see that each thing is like half the size. Instead, if I make it full size, it's like that. And then I can go back and quickly say contain it. That doesn't look very nice. So those kind of changes are also pretty simple and trivial to do, right? So I'm already making changes to my application from within my editor and from within the REPL. Now you'll notice that, you see, I said there's an alert here. There's a click action on like, what do I do when I click on this plans page? And it says alert. But we already know what needs to go in there because we did it from our REPL. So what I'm going to do is just copy, paste that over there, right? And I'm done, right? So here's a very, very simple example of something worked in the REPL. I'm going to take it and make it work in my real code now, and I've already done it. Now, you'll notice that I want to sell plants, but my plant store doesn't have any plants. In a regular native app or something, what you'll have to do is like write some factory data or some seed data generator or whatever. I have access to my database right here in the REPL. So what I can say is reframe app.db, right? So this is my DB actually right now. It's a Clojure data structure. There's nothing wrong in having a database that's entirely Clojure data structures. In fact, there's DataScript. That's what most CLOJURESCRIPT applications use today, and that's written in such a way that you use Clojure to query it. So this is my DB, and I want a plant. So I actually already have here an event that will help me add a plant, right? So you can say add plant. Now I know that the plant has a title. Let's call it fragmented plant, say, right? And then it needs a description, which says some description here. And then it needs a price. Let's say it costs $10 something, and then it will need a SKU. Now SKU is what identifies the plant. It's a stock keeping unit. So let's say SKU FP, right? And then I will also need an image index for it to say that, look, this is the image that I want there. I've added a plant and it showed up. Hey, wait a second. Hey, look, the description is not there. There you go. I made a mistake. I fixed it. I didn't go back. I didn't like wait for a compile run life cycle again. I fixed it right then and there before even I was done actually writing the code. But hey, if we've added a plant, if I wanted to add another plant, I can say plant 2, some more description here. I need another SKU, and there you go. Maybe this can have another image index. So now I've added 2 plants to my database. Let's actually look at the database. You can see that it has a plants inventory, which has 2 plants, and they're keyed by SKU, right? So I'm looking at it and I'm interacting with it. If I wanted to take something out of the DB, I can say give me, or like get in my DB, the plants inventory, SKU FP, right? And I get that plant, right? I'm still using Clojure to query what I want. Now, doing this is still definitely not equivalent to like creating your factory data, right? It's nothing like that. If I want 20 plants, like I'm not going to be sitting writing 20 plants in my REPL. What I can do, however, and what I just did here was I moved to this namespace in my REPL. You see that my REPL also now says demo app DB. What I can now do is say, and I will show you this. There is a spec there's something called CLOJURESCRIPT, which is a library for specifications and data types and whatnot in Clojure and CLOJURESCRIPT. So what I can do is use that specification to generate a plant, right? And I can also say, give me 30 plants. Boom, 30 plants, right? So what I can do is like take that piece of code that I just wrote, do seek for every plant in this. I will say dispatch add plant P. So notice that we've written dispatch add plant before. We've written gen sample whatever 30 before, and we're just building things one on top of the other, right? 30 plants. I have not left my editor. I have not left my REPL. I have not gone outside to my database console, pulled up PostgreSQL or something, and written a bunch of queries, and then like looking at all kinds of weird things in the terminal before coming back, and then writing Java to write SQL to get data out. No. I have not left my editor. I have not left my REPL. I have not left my language. So that said, I want to start over and like keep some simple data to begin with, to play with. So what I'll do is I'll reset it. So notice that I reset the entire state of my app from here, and I have to move back to the plans page. That's not a big deal. I'll say dispatch, go to the plans page, right? We're here, and then I would say dispatch, add plant. Let's go back to the fragmented plant and the other plant. So I have a REPL history, by the way, which I save all the time, so I have access to everything that I've written. So you'll notice that now I have these two plants and whatnot. And there's an add button here. This quite doesn't work. It says add to cart. So let's go ahead and implement adding to cart. Let's see what it takes to not just modify behavior, but add behavior. Now you'll notice that my DB doesn't have the notion of a cart, so let me add that back, right? Or add that in. So now I have a cart. What I will do is quickly reset it again. So you'll notice that my DB now has a cart, and I will go back to my plants page, quickly add back my fragmented plant and plant 2. All right. Now I have the ability to go back to my view and look at this thing that says add to cart button, right? And clearly here there's an alert that says add to cart. So whatever I need to do here. So let me zoom in. Okay. Now that I'm here, what I can do is register an event to add to cart. Let's call it add to cart, and I will get the database and I will get a SKU. Let's say that the cart is comprised of SKUs that go into, the cart is comprised of SKUs, plant SKUs. And all I need to say is update DB cart conjoin the SKU, and I will take this S expression, which is a piece of, it was just a list, and send that to the REPL from my editor using a command. And that's executed in the runtime now. Or basically, instead of copy pasting that into my REPL, I sent it to the REPL from my code itself. Now what I can do is call this thing. So I can say dispatch, say add to cart, and since I know the SKU, I'm going to write SKUFP. Was it SKUFP? Okay, so nothing really happened on the UI side, but let's look at the database. Hey, look, the SKUFP showed up in the cart. That's great. But that's not all I want. What I want to do is, in the UI, I want to say, look, this plant is now in the cart, right? So what I can do is then not just add it to the cart, but also in the DB, in the plants inventory, for that SKU, I'm going to add a thing called in cart ? And I will say toggle it, right? I'm going to say that, and the moment I save it, it's already sent, and you'll see that there's a warning here saying that I have overwritten your event handler. Okay? So now I'll come back here, and I will say add this thing to cart. And now if I look at my DB, you'll see that it says in cart true. Let me do that again. It should toggle it. In cart false. Great. Right? So let's bring it to true again. And let's say that now I still don't have any indication of the view. So I'll say let my background color be if in cart of plant, then it's going to be green. Otherwise, it will be orange, right? And I will say, in addition to these styles, add my BG color as the background color, and I'm done. That was it. Add to cart is implemented. If you want to go a little overboard and say, okay, let me like add some animation or whatever, I have my React lifecycle here. What I will do is, well, before I do this, I'll say, give me a bounce, let's say bounce rate, and I will create an atom. Now, the bounce rate needs to change over time, like an animation. So I need to go like one step further to create something mutable in Clojure. So our atom, and I'll say, give me an animated value. Those of you who know React will know this. And I will say start at 1, and then I will use this in here. So I need to create an animated view and say that the style here will be, say, transform, scale at bounce rate. And then I will write my React lifecycle method saying component did mount, and function, I don't care what it gets. I'm just going to say reset bounce rate to eval, let's say 5. And then let's say, so we need to animate, right? So the animate bounce rate, add bounce rate. Whoops, that's too much bounce. So let's tone it down. So maybe bring it to like 0.6 or something. So what I need to do is, instead of, so these effects will go one after the other, not because of the statelessness of Clojure, but the statefulness of Android itself. So what I will do is quickly go to the home page and come back to the plants page. Look, that works, but I don't want both my buttons to animate. I only want it to animate when in cart. When in cart, plant, do these two things. There we go. We have in cart implemented and everything working end to end. And throughout the entire time, I have not left my REPL. I have not gone to a database console. I have not gone back to code blindly, not looking at my phone or whatever, and I'm not writing chunks of code without knowing what they do. And I'm incrementally writing whatever I want to write. With that, I guess we'll go back to the presentation. Okay, so now, just have some water. Now that we understand what it is to be doing REPL-driven development, let's understand these things in retrospect. What is a REPL? It's more than a shell. It's not like your Python shell, right? I am in the shoes of my running program. I have access to everything. I have the ability to add behavior, modify behavior, remove behavior right from the REPL. I have access to my program state. It becomes all the more usable when your program state is given a lot of importance, right? You'll see a lot of Richie memes saying you're doing it wrong, state. And like, you should really look at the Clojure community for knowing how to do state right. So state, access to program state, and preferably in the editor. So this is really important because Rails has a console, Django has a console. Nobody really drives, and they have access to the program state. Nobody really drives their development from the Rails console or the Django REPL, right? And there's a reason for that. And I think one of the biggest reasons is that it's not in the editor. So with that, let's do a version of a 5 whys except backwards. So let's do why use a REPL, why Clojure REPL, and why CLOJURESCRIPT. Because each of these things has alternatives. You can use a shell to do some experiments. You can there are other Lisp REPLs, other languages have REPLs. It's not just that Clojure is the only thing that has a REPL, and there's a ton of languages that compile to JavaScript. Why use CLOJURESCRIPT, and how is that any different? So why use a REPL? For feedback. You saw Brett Victor's talk, you saw Stephen Wolfram. That's important. That feedback, like knowing what it is that I'm doing immediately as soon as I create it, is important for me to know, for me to build something quickly and effectively. Whenever I start developing something, I just pull up my editor and I start it. That's how I start my flow. And then the next thing I do is understand the problem. To understand the problem, like say I'm building a parser or something, first thing I do is like call the API, like make a quick GET request, look at the response. I'm able to look at the response into it, like, okay, I'll be able to parse it. Imagine doing parsing blindly. Like you'll have to basically be pulling your hair from all ends, trying to find out what it is, like this one small space that I missed here. You don't have any of that because you're doing all that iteratively in the REPL. So explore the problem, like you poke at all the external things to your interface, to your problem, and like try to understand what is the shape of the response, what is the shape of the request, how fast does this thing work, how fast does this other part of my problem work. And then once you have figured out your problem, you're already almost there, you just need to build the solution. And to do that also you can do it incrementally as I just demonstrated. So one of the first things that I did, being amidst good company, was get into TDD. I did TDD by example, Kinpack, and all that, and I was like a big proponent of TDD. Today I don't do TDD. I basically develop things in the REPL, and I'll tell you why, and I can contrast my experiences. I used to write tests until I got to the code that I wanted, and a lot of time looking back, I would find no value in those tests, right? Like if I would write the test after I wrote the code, I'd know that, hey, this test would actually capture all of my functionality, and this would be a more complete test. I would throw away like the 10 small tests that I wrote and replace it with one meaningful or two meaningful tests. Today, that is what I do. I do it much faster. I do it in the REPL. Every single line of code that I write is already tested. By the time, before I write it, before I put it in my editor, I have already tried out every single line of code. I have 100% code coverage at that point. And then if I want to write a test, and tests are important, and it becomes easier to write tests when you're writing only pure functions and you have only data and functions mostly everywhere. The other thing that's important and why you should use a REPL is debuggability. If the DS1 JPL example was anything to you, you'd know that. There have been times when I debugged into production, like into a REPL from my machine to find out what's going on. You can do that. You have the ability to do that. And testability. I didn't mention it here, but that's a big plus as well. So what's so special about Clojure? Well, Lisps have had REPLs for 60 years, right from the beginning. That's where REPLs came from. There was symbolics, if you guys remember, wherein your shell was a REPL. Everything down to the hardware was Lisp, right? You could write a piece of code in your REPL and hot load it all the way to the assembler. That was great, right? So following down that tradition, like a lot of beautiful things have come into Lisp, and that's why a Lisp REPL is very, very special. Whenever I've worked in the REPL, you would have seen that everything that I'm holding on is tangible. It's mostly a function or a data structure. And both of those things are first class in Clojure. And everything has a literal, all the basic data structures have a literal, you can hold on to it, you can do things to it. Read, eval, and print are functions and you can override. I can say in my REPL, I can redefine what eval does and say, like, I don't want to throw an exception when I encounter an exception. I want to do this other thing and print it very pretty or something. I have reflections. You guys are familiar with Java reflections, except my reflections are also data structures, and I can manipulate and do things with them. And that's very important to me in when I'm writing a framework. Right? Imagine the people who wrote like Renatal or the things underneath. Like so for them, these things become important. I'm not even going to the part where in Lisps, code is data, and you can manipulate all your code like you would manipulate data. I'm not even there yet, but I mean, I've already accomplished so much. So this brings me to the other question. Like there are other languages that compile to JavaScript. Why pick CLOJURESCRIPT? How is that different? So the first thing I'll talk about is how it is expressive and simple. If you've seen those menu grid example and list of pages, you see that those are very powerful data structures that were quite simple and easy to understand. I'm pretty sure you guys will have understood. Let's look at this for example. The top is vanilla JavaScript, autonomous closure script. On top, you have a class, and it has to extend another class from a library. And then you have a function that returns another function. And suddenly there's XML in between your code. And then you have a library, styles, something else, not JavaScript, and all that. Within Clojure, you just have a function. You have data structures. That's it. And that's beautiful. The other thing is seamless JS interop. CLOJURESCRIPT is not an island. There's a blog post about that wherein recently it becomes very easy for you to import NPM modules into CLOJURESCRIPT. But here's an example. What you can do is, like, if you have a very large JavaScript project, you can create a single CLOJURESCRIPT library and like strangle out your JavaScript project. But like, if you wanted to just have a simple CLOJURESCRIPT library amidst the pool of JavaScript libraries, you can do that. You can use the rest of your JavaScript in Clojure very easily. This is why CLOJURESCRIPT has thrived right from the beginning. So here are some examples. If you bother to find out, there's also very good documentation on all these things. The other thing is immutable data structures by default. React has like a portion in the README saying that if you want performance, go use immutable data structures. Well, in Clojure, everything is immutable by default. You have to like go around the world to make something that's mutable. And when you do have to deal with state, there's a lot of importance given to how you deal with state, and you should really look at some of the paradigms that the functional world pushes on you, and Clojure. So it's famous for its beautiful concurrent idioms. The other thing is CLOJURESCRIPT is on the shoulders of beautiful standard library given by Google Clojure. Like I said before, it's a part of the compilation process. So Google Clojure provides you a lot of like string libraries and whatnot that you wouldn't have to rewrite from the scratch. So like, for example, if you compare it to CoffeeScript or TypeScript or something, you don't have to write those standard libraries. You already have one, you can just leverage it. And also, Google Clojure sometimes gives you code that's more optimized than vanilla JavaScript because it will remove any unused code that you have. I've actually trimmed down the tooling here, but I must say it's splendid. It's exhilarating to work with Figwheel, which is basically a socket from your code to your browser or to the React Native packager. You don't have something like Watchman. Okay, it's way better than Watchman. You don't have files to watch for it. You just send your code over a socket. And then you have Reframe. Reframe is actually like the grandfather of all the beautiful frameworks that you have for building SPAs. This predates Elm architecture, even on like Redux and whatnot. Elm's event architecture is inspired by Reframe. That's how good it is. Right from the beginning of CLOJURESCRIPT, there has been core async. If you people are familiar with CSP, communicating sequential processes, or Golang coroutines, if any of that rings a bell, that's how you do asynchronous things, mostly in Clojure, and it's beautiful. It's like, it's basically you writing synchronous code. You write it like you would write synchronous code, but it's actually asynchronous under the hood. The only reasons why people wouldn't do this is because hiring people into this is a little difficult, and it's actually quite difficult. And it's kind of a little difficult to learn because the community is small still. I have 5 minutes, so I will rush through this. Here's my view of the spectrum. On one side, you have the guy that knows it all, a businessman, a warrior, a mechanic that can beat the metal, and a scientist and physicist all in one, right? So Tony Stark or Iron Man can accomplish all of the things by himself. He doesn't need anybody else. That's an ideal situation, where the communication overhead is zero. The other side of the spectrum is an effectively functioning robot army, or Ultron's army, if you would have, wherein there is still zero communication overhead. There's a lot of protocols and communication, but robots will follow it mechanically. There is no need for human discipline. Now, these are ideals, but are they really? Like, imagine Elon Musk. I imagine he gets a lot done because he's a lot like this guy. I imagine Infosys gets a lot done because it's like that. Or a lot of large tech companies do that because they're like that. And, a lot of us fall in between somewhere. I will say that I fall closer to this end of the spectrum. Like, wherein like 2-3 people in the team really good at what they do, and they do it all well. And the other end of the team, you'll need to rely on communication protocols, like, stand-ups, discipline, check in small commits, always push to CI/CD, create all that. So in that purview, let me talk about art and the other factors that influence how fast we got where we got. So I have the ability to have a full picture. I have the picture of both the front end and the back end. I'm not at a place where, like, I don't know what those back end people do. Like, I don't know if this thing is slow or fast. I can actually go read the code. I can say that, okay, this is what it is, and make a PR on the back end. Like, okay, this is what's happening on this thing. I know this is slow, and I can make decisions in the front end accordingly. I make really quick feedback cycles. So if I want improvement on an API, what I do is quickly try out an API and look at the structure. Hey, look, there is something in this that's missing. Let me quickly talk to my backend team and figure it out. That's how fast it is. I don't need to wait for a week to get there. And so I end up getting front-end, like, beautiful APIs. The other thing, like, moving more towards the side of the spectrum, is that there are no specialists. There's not one person who's sitting and writing SQL queries. There's not one person taking your jars and deploying them. Those people don't exist in our ecosystem anymore. But maybe it's time for us to move further along that edge of the spectrum. The other side is, like, people who have a Java backend and an Android frontend, or people who have a Node backend and a React Native frontend, can relate to this, right? Like, you take your code from the backend, put it in the frontend, or take the code from the frontend, put it in the backend. I've actually done this. We've taken code across projects even and moved them. So that's a great ability to have. So I can share code not just from front and back end, but also across projects. I can use the source. If I want to know how something works, I can go to the back end and figure out what it looks like. If my backend developers, like, find, oh, this guy's on the other side of the world, I want to fix this right now, they can dig into the React Native front end and poke at things and fix things. And PR is across front end and back end, and I don't have to wait to get to my CI/CD environment. If I set up Fastlane, it's mostly the same. The rest of the tooling and the release process is the same as any backend service. So that's it. That's all I wanted to talk about. But I just want to say this: it might not be React Native, right? Who knows with the patents and whatnot. It might not be a CLOJURESCRIPT. Maybe it'll never cross the chasm and it'll die in a year or so. But what we do need to take back from us is the way we create things. This is not like working blindly in a text editor is not it, right? And let's see how we can push things forward. There are my friends who work like writing pure script and writing frameworks that are beautifully descriptive in order to make full mobile applications within 10 lines of code. That's beautiful. We've been writing generative test suites where we write, DAGs where we describe the flows and let this entire app run by itself and just watch it run. That's beautiful. Let's move on to, like, more of those important things, and let's try to get somewhere here. Maybe the future is not like one single guy who can do it all, or one robot army that can do it all, but maybe like a couple of people that can make a robot army to do it all. And that's all I have. Thank you.